This video is going to run through some techniques we can use to solve nonlinear systems. But let's start by doing a brief review of linear systems and the three different methods we can use to solve them. So I have on the screen an example of a linear system. So a system simply means we have more than one equation, and linear, these are equations of lines. So if we want to solve a system of equations, we're trying to find a point, an xy, that satisfies both of these equations. And there's three different ways we can do that. We can graph and figure out where they intersect. We can use the method of substitution, and we can use the method of elimination. I'll run through these three methods. So graphing, these are two lines. I can graph each line independently on the same axes. So 2x plus y equals 3. If I minus the 2x, that's the line y equals negative 2x plus 3. The y-intercept is 3, so I'll start at 0, 3. And the slope is negative 2. So that means go down 2 over 1, down 2 over 1. And I've plotted several points. I can connect the dots now. X minus y equals 6. Let's see, if I minus the x, negative y equals negative x plus 6. Multiply everything by negative 1. I get y equals x minus 6. So minus 6 is my y-intercept. I'll plot that on the y-axis. And then the slope is 1. So that means up 1 over 1, up 1 over 1. And I can just follow that pattern to graph some more points. And in green, there's the graph of x minus y equals 6. The solution to this system is a point that satisfies both lines. In this case, the two lines appear to intersect at the point x equal 3, y equal negative 3. So that's the solution to my system. Now, graphing is a great way to visualize the problem, but if you're solving by hand, without using a computer or other technology, it can be hard to get a really accurate solution since you're just relying on your ability to estimate where the lines intersect. So let's run through our other algebraic methods. The method of substitution is when you solve one equation for one variable and you substitute it or plug it into the other equation. So for example, I can take my first equation, 2x plus y equals 3. I can solve for y by minusing the 2x. So y is minus 2x plus 3. Then I take that expression for y and I plug it into the other equation. That gives me x minus the quantity negative 2x plus 3 equals 6. I'm going to distribute that negative, that subtraction. So now I get x plus 2x and then minus 3 equals 6. Combine like terms, 3x minus 3 equals 6. Add the 3, so 3x is 9. Divide by 3, x is 3. So these lines intersect when x is 3. And then to find the y value, I'm going to take my solution for x. You can actually plug it into either of the equations, but I'll plug it into that equation that's already solved for y. So if x is 3, y is negative 2 times 3 plus 3, or negative 6 plus 3, or negative 3. This is the same solution we saw on the graph. The point 3, negative 3 is my solution or point of intersection. Finally, the third method we can use on linear systems is called elimination. That's where we add multiples of the equations together with the goal of eliminating or canceling out one variable. So for example, if I want the x's to disappear when I add these two equations together, I'm going to need a negative 2x in the second equation. I want one of my variables to have equal but opposite coefficients. So I'm going to take my second equation, I'm going to multiply everything by negative 2. That gives me negative 2x plus 2y equals negative 12. Then if I add that to the first equation, 2x plus y equals 3, the x's disappear, and I'm left with 3y equals negative 9. This is something I can solve for y by dividing both sides by 3, and I get y equals negative 3. Now I chose to eliminate the x's, but I could have also eliminated the y's. In fact, I wouldn't have had to do any work. Just add the equations together and the y's would cancel out, and that would give me 3x equals 9. So you can eliminate either variable. And then once you know what one variable is, you can plug that into either equation. So I'm going to plug my y equals negative 3 into my second equation. So x minus negative 3 equals 6. That means x plus 3 is 6, or x equals 3. So same set of solutions. Now I wanted to run through these three methods because what we're going to be focusing on in this video is solving nonlinear systems. And we can use the exact same three methods to attempt to solve nonlinear systems. So here's a nonlinear system, y equals x squared minus 2, x minus 2y equals 1. To solve, we want to find points that satisfy both of these equations. So if I want, I could graph y equals x squared minus 2 is my parabola, but it's been shifted down 2 units. X minus 2y equals 1 is a line. I could solve it for y, or I'm just going to plot some points. If y is 0, if I plug in 0 for y, I get x equal 1. And if I plug in, let's just plug in 1 for y. If I plug in 1 for y, I get x minus 2 equals 1, or x equals 3. So I know that this line goes through the point 1, 0, and then x is 3, y is 1. I can kind of continue the pattern and draw that line. And so visually I can see in this particular case where we have this specific parabola and this line, there's actually two solutions or two intersection points. One point appears to be at negative 1, 1, and the other intersection point is kind of hard to read. It's at about 1.5, so 3 halves, and then about a fourth. Now, just like with our linear systems, graphing is a great way to visualize the total number of solutions, but it can be hard, especially in this case. I know the answer is 3 halves, 1/4, but it's actually really hard to see that from the graph. And so we're going to use an algebraic technique to hopefully get these same solutions. So we can also use that method of substitution. That's where we take one equation, solve it for one variable, and plug it into the other. In this case, the first equation is already solved for y. Y equals x squared minus 2. We can take that x squared minus 2 and plug it in for y in the second equation. That gives us x minus 2 times x squared minus 2 equals 1. If I distribute the negative 2, I get x minus 2x squared plus 4 equals 1. Set one side to 0, negative 2x squared plus x plus 3. I think quadratics are a little bit easier to solve if the first term is positive, so I'm just going to go ahead and multiply everything by negative 1. So positive 2x squared minus x minus 3 equals 0 is what I need to solve. That's a quadratic equation. I'm going to solve it by factoring, but if you can't factor or just can't find the factors, you can also use that quadratic formula. I'm going to use the trial and error method, so let's see if the first term is a 2x squared. If I can factor this, it's got to be a 2x and a 1x. And then if the last term is a 3, it's got to be a 3 and a 1. And if I kind of just guess and check and play around with where I put the numbers, if I put the 3 with the 2x and the 1 with the x, then my inner terms are 3x, outer are 2x, If the 3x is negative and the 2x is positive, that'll give me that middle term of negative x. So my factors are 2x minus 3 and x plus 1. If I set those factors equal to 0 and solve for x, I get x equal 3/2 and x equal negative 1. This is representing the fact that these two functions intersect at two different points. To find the corresponding y values, we can take these two x values and plug them into either equation. I'm going to plug them into the y equals x squared minus 2. So if x is 3/2, y is 3/2 squared minus 2. That's 9/4 minus 2. Or 9/4 minus 8/4, that's 1/4. So one solution is 3/2, 1/4. If I plug negative 1 in, y is negative 1 squared minus 2. That's 1 minus 2 or negative 1. So my other intersection point or my other solution is the point negative 1, negative 1. All right, let's see if we can also use that elimination method. To use the elimination method, I would move the terms around so you have constants on one side of your equation and variables on the other. So let's see, if I take the x squared and move it to the left-hand side, I get negative x squared plus y equals negative 2. And then x minus 2y equals 1. Now with nonlinear systems, the elimination method isn't always going to work. But in this case, we can actually eliminate these y's if the first equation had a 2y. Notice we're not going to be able to eliminate the x's because I have an x squared in one equation and an x in the other. But I can eliminate the y's. So I'm going to take the first equation, I'm going to multiply it by 2. That gives me negative 2x squared plus 2y equals negative 4. Now if I add the two equations together, well, we can't combine the x and the negative 2x squared, so we'll just write that as negative 2x squared plus x. The y's disappear. 1 plus negative 4 is negative 3. And if we set this to 0, this is the exact same quadratic we had in the previous example. So I'm going to stop here since we've already solved this equation. But we would continue in the same way. We'd use a quadratic formula or try to factor to find our solutions. Let's take a look at another example. We want to solve x squared plus y squared equals 4 and x plus y equals 1. This time, I'm going to go straight to the substitution method. And the reason is, when we're solving by hand, graphing really isn't going to give us an accurate solution. The elimination method is not going to work here because I have an x squared in the first equation and an x in the second. I have a y squared in the first and just a y in the second. So I'm not going to be able to get either the x's or the y's to cancel out. So instead, I'm going to use substitution. I'm going to take the second equation and solve it for y. To solve for y, I just have to minus the x. So y equals 1 minus x. I'm going to take that expression, that 1 minus x, and plug that in for y. So now I have x squared plus 1 minus x squared equals 4. This is another quadratic equation. To solve it, I'm going to expand. So let's see, we've got x squared, and then 1 minus x squared. If we FOIL that out, 1 squared is 1. We get minus x plus a minus x. That's a minus 2x. Minus x times minus x is plus x squared equals 4. If I combine like terms, I get 2x squared minus 2x plus 1 equals 4. Minus the 4 to set one side to 0. So 2x squared minus 2x minus 3 equals 0. In this case, we actually can't factor this. So I'm going to have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. That becomes positive 2 plus or minus 4 plus 24 all over 4, or 2 plus or minus 28 over 4. 28 is 4 times 7, as 4 is a perfect square. So we can write that as 2 plus or minus 2 root 7 over 4. And then we have a common factor of 2. We can reduce this down to 1 plus or minus root 7 over 2. So we actually have two solutions. And just like in the previous problem, we're going to take those two solutions, we're going to plug them into any equation. I'm going to plug into this y equals 1 minus x. So y is 1 minus, let's do 1 plus root 7 over 2. That's the same thing as 1 minus a half, and then minus root 7 over 2, or 1 half minus root 7 over 2. So one solution, when x is 1 plus root 7 over 2, the y value can be written as 1 minus root 7 over 2. If I plug in my other solution, when x is 1 minus root 7 over 2, y will be 1 minus a half, and then minus a minus becomes plus root 7 over 2. Combine like terms, y is 1 half plus root 7 over 2. And so my other solution would be 1 minus root 7 over 2 for x, 1 plus root 7 over 2 for y. And so those are my two solutions. Geometrically or visually, what's happening here, x squared plus y squared equals 4 is a circle of radius 2, and x plus y equals 1 is a line with intercepts at 1, or I should say 1, 0, and 0, 1. And there are two intersection points that we have found. All right, here's my last example. Y equals 2x squared plus x, and x squared minus y equals 4. This problem is set up really nicely for substitution. So I'm going to take the first equation, which is already solved for y, and I'll plug that into the second equation. That gives me x squared minus the quantity, 2x squared plus x equals 4. If we distribute that negative, we get x squared minus 2x squared minus x equals 4. Combine like terms, negative x squared minus x equals 4. Set one side to 0. So negative x squared minus x minus 4 equals 0. I'm going to multiply everything by negative 1, just because it's easier for me to work with positive coefficients. We can't factor this one because product of 4, sum of 1, that's not possible. So I'll use the quadratic formula. X is negative b plus or minus b squared minus 4 times a times c, all over 2 times a. That becomes negative 1 plus or minus 1 minus 16 over 2, or negative 1 plus or minus root negative 15 over 2. Square root of negative 15 is not a real number, and when we're solving linear systems, we really are trying to find those real solutions, because we're trying to find intersection points on a graph. So this system has no solution or no real solution. Graphically, what that means is the two functions are never intersecting. We have two different parabolas. Y equals 2x squared plus x is shown in red, and then x squared minus y equals 4 is shown in blue, and these two parabolas never end up crossing each other. All right, that was my last example. As always, let me know if anything from this video is unclear.